Hey guys, Miss Harper here for reporting category 4, quadratic functions and equations. Alright, let's go ahead and dive into our key vocabulary here. If you remember, there's a lot of key features to remember in regards to our quadratic functions. So let's talk about some of those things. One of our main points we want to talk about is our vertex. Remember, we describe our vertex using the word maximum or minimum. So that's the highest point or the lowest point. So if you want to look over here at this graph to the right here, this guy would be my vertex, and that's at the point 2, -4, and that would be considered a minimum. All right, that is the lowest point of our graph there. Another thing to talk about is our axis of symmetry. Axis of symmetry, I'm going to abbreviate that. Remember, we have a formula that says x is equal to opposite b over 2a. Remember, that's a b, not a 6. So let's look at our axis of symmetry over here. Now remember, the two parts that are going to be related is your axis of symmetry and the x value of your vertex. So this is my axis of symmetry, and the equation here is x equals 2. All right, so remember, your axis of symmetry is always going to be a vertical line, so it's always going to be some x equals some number, so you should be thinking hoi vux, okay? Hoi vux. All right, other thing we have are the rocks. All right, remember that stands for roots, zeros, root zeros, x-intercepts, and solutions, and they all mean the same thing. That is where our graph crosses the x-axis. So here is one of those rocks. Here is our other one. Again, we call those our x-intercepts. This one is at the point 0, 0. This one is at the point 4, 0. All right, then we could mention our domain. All right, domain is talking about our x values, and if you remember, for our quadratics, this thing is going to go on and on forever and ever to the left and right. So 99% of the time, the domain for our quadratics is going to be all real numbers. Remember, this is just a fancy word or a fancy way to write all real numbers. All right, then we have our range. The range is talking about our y values. And I wanted to say that he is related to, so range y values, it's always going to be y is greater than or equal to, or y is less than or equal to, and it relates to the y value of our vertex. So if I were to look here at the y value of my vertex, this would be the lowest point of my for my y values. So my range, I'm going to put that up here. So look at the y value here. So the lowest point would be down here at -4. And it's anything greater than that, so it's going to be y is anything greater than or equal to 4. All right, now let's say our graph was flipped upside down, kind of like the graph right down here. Okay, then it would be anything less than if it opens down. Okay, and one last thing to remember about these guys is our standard form is y equals ax squared plus bx plus c. So remember, you have to get all of that stuff in order on the same side of the equal sign before we can even do anything. Now remember, your best friend for our quadratics is going to be your calculator. So make sure you have him out and available. All right, let's shimmy down here and point out some of the key features of this thing. So the graph of the quadratic function of g is shown below. The coordinates of the x-intercepts, y-intercept. Okay, we're going to find all these things. Okay, so what is the maximum value of g? So our maximum value, we're going to be talking about our vertex here. Our maximum is going to be right here at this point. Kind of hard to see on the computer, but if you look closely at your paper, you will find that to be at the point 2, 9. And that guy is our vertex, and we call him our maximum. All right, the solutions. Remember, solutions, you got to be thinking your rocks here. I know, it's ridiculous. Why did they give 4 different names to the same thing? Don't know. I didn't make the rules. So anyways, we're talking about our x-intercepts here where they cross the x-axis. And again, if you look closely at your note sheet, you should see that at the point -4, 0, and 8, 0. Now, I do want to point out, sometimes they write this in a weird way, kind of like whenever we were describing our domain, we list it using brackets, and that shows a set of numbers. So if we put something in parentheses, that describes a coordinate point. Now, sometimes on your STAR test, you might see it listed like this. Now, this is not describing a coordinate point because it's in brackets, not parentheses, but I just wanted y'all to be aware it could say something like that. All right, the y-intercept is where it crosses the y-axis, and that would be right there, and that is at the point 0, 8. Okay, and then our axis of symmetry. Remember that your axis of symmetry is always going to be related to your maximum or minimum, which is also your vertex. So I'm going to put in parentheses, look at vertex. Okay, and we're actually talking about the x value of our vertex. Remember, your axis of symmetry is what splits this thing in half. All right, and it's always going to be a Hoy-Vux situation. It's going to be a vertical line, so it's always going to be x equals, look at the x value of your vertex, which was 2, or where it crosses your x-axis, which is also at 2. X equals 2. Off to the side here, I am going to list out the domain and range. Remember that your domain, 99% of the time, is going to be all real numbers, and your range, in this particular case, has to, remember, it relates to your vertex. So up here, I can't mark the lowest point for my y values, but I can mark the highest point, and that's crossing there at 9. So it's always going to be y is something or something to this 9. So is it going to be values greater than +9 or values less than +9? All right, yes. Less than or equal to anything less than or equal to 9. So I have all of these y values below 9 that I will use. Awesome, awesome. Let's shimmy down. Which statement about this is true? So the zeros, you got to know what those are. So remember that zeros, we're looking and talking about the x-intercepts here. So what I would do is get your handy-dandy calculator out, go to y equals, and we're going to plug in that equation. So I have -x² minus 2x plus 15. All right, and again, make sure that before you plug anything in, it's either equal to 0 or equal to y. We got to get all that stuff on the same side. Then we can go look at our graph, and let's see which of these answer choices is true. All right, we can very clearly see where it is crossing our x-axis, and that would be here at the point 1, 2, 3, 4, -5 and +3. So -5, +3, that would be G here. Now, be careful. Now, if it was crossing at some weird place where it wasn't so obvious and my answer choices were a little bit closer, remember you can always do the second trace function and we can find our 0. You got to move that little cursor. Let's see if I can find him. Oh gosh, this computer. All right, so there's my little cursor. Remember to find the 0, it says left bound, so I need to move my cursor to the left side of that point. So, oops, didn't mean to do that. All right, so to the left side, and then I'm going to move my cursor up here to the right side. And I want it to take a guess, so I'm going to hit enter one more time, and it tells me I have a 0 at -5, 0. Now you could do the same process over here to your right x-intercept as well. All right, -5 and 3. Okay, cool. Parameter changes. Parameter changes. Again, your calculator is going to be your best friend here. A couple things we need to remember is our parent function. Parent function. Anybody remember? It is y equals x². He is super basic. He is the most basic form of our quadratic functions. Make sure you remember him. He looks a lot like this, where his vertex is at the point 0, 0. So for our parameter changes, what we mostly want to remember is to plug our graphs into y equals and then compare. All right, so let's see what an example of that might look like. Oh, next page. All right, so for example here, kind of a weird question. The graph of f of x is equal to x squared is transformed to create the graph of h of x equals 2 times whatever f of x was. Which graph represents those two graphs? So I knew that f of x was equal to x squared, so I'm going to plug that in right here. So h of x is now going to be equal to 2 times x squared, or 2x squared. All right, so I'm going to plug those two things into my graphing calculator. So I'm going to go back to y equals. I'm going to plug in my parent function, y equals x squared, and my new graph, 2x squared, and I'm just going to go compare the differences. So here comes our parent function, basic, and here comes our new equation, 2x squared. And we just want to note the differences. So what happened to this guy? Did he get wider? Did he get skinnier? And the answer is he got more narrow or skinnier. So I just want to see a graph that reflects that. So they are showing our new graph as the solid line. So I'm trying to see which one of these makes most sense. H is the solid line. He didn't shift up or anything. F, H. Sorry, I'm just making sure I got the right one here. H is our new graph, and he was the skinnier graph. We have an answer there of J. All right, he got a little bit skinnier. Just pay attention to what they're labeling here. So H was our new graph, and he was skinnier than our original graph of F. Cool. All right, quadratic functions Q and W are graphed on the same coordinate grid. The vertex of the graph Q is 18 units below the vertex of graph W. So I'm going to kind of draw a little picture here to give myself a visual. So I have some function Q, or I'm going to draw W. So here's W, and let's call this guy Q. And it says that the vertex is 18 units below. So let's pretend that this is 18 units below, and this is Q. All right, so that gives me some idea which pair of functions could have been used to create this. So again, your graphing calculator is going to be your best friend here. Let's go to y equals, plug in those answer choices if you don't remember too much. So let's see. The first one compares. I'm going to keep that parent function there, y equals x squared. And then the new graph of Q was 18x squared. And let's see, is this graph going to sit 18 units below? And no, it doesn't. All right, they actually have the same vertex. So again, we're looking for a vertex to be 18 units apart. So now it should be down to my next answer choice, where I would have x squared plus 18. Go look at my graph again. So there's my original graph for my parent function. And here comes the new one, maybe. Actually, I forgot, you can't actually see him. I'm not going to take the time to zoom out, but he's actually has a y-intercept up there at positive 18, so he's not exactly 18 units below, but that gives me a clue to go look at what happens to if I change it to option D, where it says x squared minus 18, and go look at my graph. And here he comes. So again, there's W of x, and there is Q of x, and odds are that guy is sitting 18 units below my current graph. All right, and take a look there. If I took the time to really figure out where those vertexes are, my guess is that is 18 units below. So he is going to be my answer choice there. Now remember, if you can kind of remember some of those properties, that number does shift our graph up and down. All right, so again, plug them into your calculator and go compare. That is going to be your best bet. All right, and then solving with quadratics. The biggest, most important rule here is that it must be in, okay, I want to say standard form, but it doesn't always necessarily look like standard form. Oops, that was real ugly. Which is ax squared plus bx plus c equals 0. All right, so now it doesn't always necessarily look like this, but my point is we want everything to be on the same side and it be equal to 0 or be equal to y. All right, so get all your numbers onto the same side before you plug it into your calculator. And then with solving these, there's lots of ways to do it, but the easiest way is to just plug into your calculator into y equals, go look at your graph, and then use your second trace functions. There you can find your max, min, and also your zeros. All right, so the max, min, this is talking about your vertex, and then your zeros, that's talking about the rocks, the roots, zeros, x-intercepts, and solutions, or your x-intercepts, okay? Other options outside of that, you could always factor. Then set your factors equal, then set equal to 0, and solve for x that way, but nobody really likes to do that. And then your third option is the quadratic formula. He works every time. Quadratic formula. Remember, you are given that equation on your star chart. All right, so again, best option, get this thing to equal 0 or equal to y, and then just go plug it in your calculator, okay? So for example, we're given the sum of the first n consecutive even numbers can be found using this function, where n is greater than or equal to 2. What is the value of n, or that's kind of representing x for us when the sum is 156. So I'm going to replace this with x and y, so I have y equals x squared plus x, and I'm just going to go pop that into my calculator. So I have y equals x squared, oh gosh, y equals x squared plus x, and go look at let's go look at our table. So again, if we look back at the question, it says find when the sum is equal to 156. Well, where is the sum? Well, the sum we are talking about right here, that s, which is talking about our y value. So plug that in and go look for whenever y is equal to 156. All right, and it takes me a minute to scroll on the computer, but you can see this here. I found where y is equal to 156, and that's when the value of n is equal to 12, or whenever x is equal to 12. And then our last one, all right, so find the solution. Remember, solution is rocks, or where it's going to cross my x-axis. Now the only issue is here, this is equal to 32, and I need it to be equal to 0. So the way that we do this is subtract the 32 over 2 times x minus 7 squared minus 32 equals 0. So this is what I was mentioning before. It's not necessarily equal or in standard form, but it is equal to 0 or equal to y, which is what we have to do first. So I got that done. Now I'm going to go to y equals and plug that into my calculator. I have 2 times x minus 7 squared minus 32, and I'm going to go look at my graph. So again, the solutions are talking about our x-intercepts. I want to see where those things are intersecting. I'm going to go zoom back to my standard screen and see where are these things crossing my x-axis. All right, so I see one of my intercepts at 3, and again, I bet the other one is down over there at 11. Looking at my answer choices, this is going to be my best answer choice here. Okay. All right, if you have any other questions about your quadratics, go see your teacher. Thank you.